And my name is Janine Stevens. Welcome to our Engineering Design and Development Showcase for 2021. So Engineering Design and Development is a course that our Academy juniors and other Bartlett High School juniors and seniors can take. It is a class where the students select a problem that they would like to solve. They work through the entire engineering design process to come up with a solution to that problem. They build it, they test it, and then they decide what kind of modifications they would make to their project to make it a viable product. So today we have 21 different projects that we are going to showcase for you. And they're spread out all through our area gym right now at school. We apologize if it's a little bit loud in here, but we believe that you guys can hear us reasonably well. I have two hosts that are going to be taking you through the showcase for the next hour. And that is Khan Oda, he is a senior in our academy. And Ronan Shah, he is a sophomore in the academy. So I'm going to hand it over to them and they're going to take you through. So welcome.
All right. Hey guys, my name is Khan Oda, as Mr. Stevens mentioned. I'll be hosting you guys today. So if you guys have any questions, please let us know in the chat and we'll try to keep things moving. So yep, thank you.
Hello guys, my name is Ronan Shaw. I'm a sophomore and I'm the other host. And like Khan just said, if you guys have any questions at all, just let us know in the chat and we'll be happy to help you guys.
Okay, hello everyone. My name is Evan.
My name's Dylan.
And my name's Rowan.
And this is our solution to help combat distracted driving, specifically when using one's mapping program while on the road. So this all started about 6 months ago when I had a pretty close call while driving. So I was going to the store using trusty old Google Maps, and I looked down, looked back up, and all in the span of a second, found myself swerving just enough that I was headed towards the oncoming lane. So I frantically turned the wheel and made it back okay, but that day stuck with me because I was almost one of the 10 people who perish daily due to distracted driving.
So we decided that something needed to change. So to solve that problem, we created this design, which is essentially a heads-up display. And this design has come a long way from originally being a projector to turning into this simple and effective design that uses the user's own cell phone as well as a GPS app to use the physics of reflection.
So using a special app called Sidejic, which comes equipped with a heads-up display mode that actually flips the view of the text. As you can see, it's all mirrored right now. And this combats the mirroring effect when reflecting something on a pane of glass. So in combination with this angled pane here, a driver can effectively view the image on the screen while still being able to see through the screen and onto the road.
And due to the reflective film, our device works in every condition, whether it's sunny, dark, or light out. And because of this special flexible, can you bend it for me? Due to this special flexible and bendable flap, our device is easily adherable to the dashboard as well as removable. Oh, and because our device is modular, that means everything is detachable and reassemblable at will. This makes for easy travel and storage.
What makes things even better is that during testing, we found that our device actually works and it helps us to some degree while we're driving. And during testing, we used multiple vehicles and different cell phones, and all of our tests ended up becoming positive. And testing actually resulted in us creating two different types of acrylic glass. This one is for the daytime and makes it easier to see with all the sunlight and the clouds. And this one's for the nighttime, which is easier at night.
And ultimately, it works successfully. So much so that once we're done today, we plan to take it home and, at least for me, use it in my daily life. Thank you, everyone.
All right, thank you, Evan's group. We will be moving on to the second group now. Okay, we're gonna skip the second group for a second. Move to the third group.
Hi. Wait. Hold it. Okay, so do we have to pass it around? All right. Our group is Jazzy Designs, and we made Big Blue, the nickname for our drill bit container. I have to hold it closer. Okay. Yeah, we're Jazzy Designs. Our container is called Big Blue. It's a drill bit container. Basically, our goal with this project is to improve on current drill bit container designs. They're clunky, they're hard to use, they're not really portable, and we wanted to create something a bit sleeker, more easily used, and something you can bring with you during a project.
Okay, so we looked at many past solutions and we had many like brainstorming designs and initial designs before we came up to our final design. So our final design, as you see here, it's pretty big and clunky, but it has a ergonomic belt clip, magnets on the back to hold the drill bits on the back to attach to a case. One of the magnets is indented to hold the screwdriver bits, and then so also has the hinge here is open and closed. For a latching mechanism, we use a friction lid. So basically just a bit of a interference using that to keep the lid closed and opening it so it makes it easier to open and to close the drill bit during a project. On the inside, all the drill bits just have the individual holes with a bit of tolerance to make it easier to put the drill bits in. Okay. Oh, okay. So for our testing, it went. Oh, okay. For our testing, it went pretty easily. And building, it was just pretty much attaching everything with super glue and screws with this thing. So for our testing, everything went really well, except there was a bit of issue with our hinge, as the screws are puncturing the filament and causing a breakage in the 3D print and making it rough. So to solve this in the future, we're going to try and use more threaded inserts to get a better hold and to not destroy the filament, as well as make the entire thing a bit more sleek and compact, because this is pretty clunky and has sharp edges. And that includes cutting this down a bit to make it more like thinner to save in filament and costs. So overall, it's going to cost around $12 to produce. And yeah.
All right. Thank you guys so much. We'll be moving on to the next group.
Yeah, you're not important to us.
Watch in the background.
Okay, we have fibers. Or do you want me to take off the mask? Huh? Oh, move it closer. All right. So typically, when you're at a hospital, you're gonna be hooked up to a machine. This machine's gonna measure your heart rate, your blood pressure, your temperature, and your blood oxygen. This is what you would call a vitals monitor. Typically, these would go for like nearly $500 to $1,000. We thought we should design one for the layman that would be cost effective as well as accurate. We accomplished this by creating one that's theoretical manufacturing cost is nearly $90, under $100, and which is 1/5 of the original standard prices.
So some constraints and criteria we put on our project was making it have data storage and data exportation in order to send your vitals data to a doctor. We also added a size limit in order to make it fit in your home properly and for it to be easier to navigate through, as well as putting the price limit as earlier mentioned. We also added a touchscreen display, mostly for making it easier to use, specifically for elderly people.
So here are the pest solutions we base our design on. So we have the check me, which is the low end of it. And then all the way through the Connex, which is the high costly, high performance version we're going for. And then in the middle, we have the Clio, the AMD 8400, and the Caretaker.
Sorry. Now to actually make the device, we first had to 3D model this in Fusion 360. This is our initial design. This allowed us to actually figure out how we would place every circuit and how we would have the devices. Also, we created schematics. This is for the electronics. This will help us figure out how we're going to connect everything and where we're going to place everything. These schematics were then changed into PCBs. These PCBs allow us to actually use the microchip in the physical world rather than virtually. Also, from this initial 3D model, we 3D printed it to get our case. And we got one circuit like this. The other way was to breadboard it, which is a way to prototype circuits so it's easier for you to change stuff and then come to a better result. We also created a program that allows you to see the vitals more easily. Then for testing, we hooked up the blood pressure circuit to an oscilloscope, which allows you to see the signal. And we used an Arduino to decode our temperature sensor and display the data.
From here, there's a variety of different things that we can improve on. One is decreasing background noise through the use of RC and CR circuits by decreasing the range of frequencies that we intake. Another is by improving our UI by using a larger screen or streamlining our button use. Another is decreasing dead space that we currently have in our product and making it smaller so it's even more portable and maybe even pocket sized. Implementing a handle made of probably TPU or some sort of cloth fiber that is that can be compacted flat and still raised up to be held, similar to how the power supply is being used, by using a battery instead of a power supply, and by injection molding for industrial use using polycarbonate or polyethylene, which are both highly durable, highly chemical resistant plastics. Thank you so much. We'll be moving on to our next presentation.
Yeah. Okay. Ready? Yeah. I'm Ethan Colano.
I'm Riley Medendorp, and our project was a wireless door closer. So the reason we did this was because we found that a lot of people in wheelchairs struggle to open doors, and we also found that a lot of everyday people would consider using it as well. We found that 70% of our surveyed participants found it annoying when a door was left open in their house, and over 75% found it would consider buying this product.
We can barely hear you.
Our similar solutions that are out on the market right now, such as automatic door closers that close as soon as you release the door, are not wireless and you can't like do it whenever. And then industrial type solutions like these right here can cost upwards of $1,000, and that's not practical for everyday use. So our proposed solution was something similar to the final. It has two motors, Arduino, and a Bluetooth module. So how it works is that you send out you press a button from your phone. It connects to the Bluetooth module, which sends one to the Arduino, and which closes it. So to demonstrate, you press start right here, and that'll be attached to a door, and like theoretically, that'll get pulled in, and then this piece right here will come and close the door. So how this works is that once you press the button on your phone, it'll send out a 1 to the Bluetooth, and the Arduino will read that and send out the motor and pull it in. And then afterwards, it'll pull the second motor in. And you can also stop it by pressing the stop button. You can't really see it right now, but you press stop and the function stops. So the final testing showed that on an actual door, it doesn't have enough torque to close it due to the Arduino only outputting 40 milliamps of power. So we tried to combat this with the transistor. We got it up to like 300 milliamps, but that's still not enough.
All right, thank you guys. We'll be moving on to our next presentation.
Start now. All right. Hello, everyone. We are Sidewalk Solutions, and our goal as a team was to create a product that would help people shovel. So we were inspired by the problems that we ourselves and many others have experienced while shoveling sidewalks in particular. And as it turns out, about 1,700 people got injured while shoveling snow in 2014, just in Illinois. And most of these people get injured because they're trying to shovel and they don't own a snowblower, often because they're too expensive. A high-end snowblower can cost upwards of $1,000 to $3,000. And so our goal as a team was to create a solution that would reduce cost and also provide an alternative to using a snowblower on a path or sidewalk, while also reducing, as I said, cost, and then improving safety and efficiency while shoveling.
So we initially looked at some alternate solutions that other people had in their patents for shovels. And we took some ideas from these, such as an extendable blade to change lengths and using wheels so you didn't have to lift the entire load. We put this into some of our initial designs and then eventually remodeled and added detail until we had our final design.
So to build our design, we built the blade out of 3-inch thick steel, and then we built the frame out of electrical conduit. We welded most of the joints together. However, we used epoxy for a few of them. While testing with the narrowest setting, we had an 18th inch width clearing. And then at its widest, we were able to clear up to 27 inches. We did one test with a very deep pile on the narrow setting, and even then we're still able to clear up to 18 inches. So then to meet our criterias, we met all of them except for one, which was an issue, was it is very large. It's not very storable. So if we did it again, we would have a way to remove the handle so that it could fit in a smaller space. Then in addition, we would attempt to reduce the weight a bit by using thinner steel for the blade and perhaps some other lighter materials. However, overall, it met most of our criteria and we consider it a success.
Thank you. Moving on to our next presentation.
Hello. Oh. All right, so our project is a reinvented sun visor. So the main problem that we had when we were thinking of problems was that the sun visor doesn't really cover the full car as we wanted to, and it doesn't cover the front and the side window. So we were making a visor that does both those jobs and covers more of the window.
Here are our 3 initial designs, and we eventually got it down to our final design, which involved a rotating hinge and 2 acrylic tinted windshields.
So after we created the visor, we started to do the testing. So we did do it on 3 different cars, which is all 3 of ours. We did it with 3 different cars because we know that every visor has different lengths, different widths, materials. So we wanted to make sure that it fits in all sorts of kinds of criterias. Everything did pass with all of our criterias to check if it's scratch resistant, if it's breakable or not. We also did check if it's UV resistant. The main idea, which was the UV resistant, did pass. The only problem that we forgot about was that the visor needs friction, and when we rotate it, it's a little bit too loose. But other than that, when it's closed, it fits perfectly and it does not cause any damage to the driver. Yeah. Is that all? Yeah, we're good.
All right, thank you guys so much. We're moving on to the next group. Okay, we're skipping this group for now.
No, don't stand in front of the board.
Are we ready? All right. So my name is Chris.
I'm Shannon.
And I'm Nick.
And that's Nikki. So our goal was to create a more eco-friendly pizza box. So when we were doing our research, we found that 33,000 tons of pizza boxes are thrown into landfills each year. So our goal was to actually reduce that number. And Nick, if you'd like to explain.
So what we did is we created a stackable pizza box. We did this by creating a pizza box like this and a pizza box like this. You put a pizza in both. You would, someone hold it. You would then stack them until the desired amount of pizzas was reached. Then you take a latch like this, stick it on top, fold the side latches down to the bottom box, securing it. We found that if you do this per extra box ordered after the first one, you save 30 to 40% of cardboard.
And then an additional way to save cardboard is we implemented a break apart design. So in a survey of 69 participants, we found that actually 72.5% of people use disposable dishes like paper plates or styrofoam plates when they order out a pizza. So we implemented the paper plates within the design so you could actually break apart the pizza box and then use that as the plates instead of using paper plates or disposable dishes and just further adding on waste.
All right, if there's anything else you guys have questions about.
All right, thank you so much.
Thank you so much. Wait, no, you gotta give us a minute. Hold on. Dude, I hate you, Ronan. Actually. Okay. Okay, hi, I'm Harima. And I'm Abby. And we're 2/3 of Ash Industries. So the product that we designed is... Dude, don't do that. You're gonna mess me up. Okay. You want me to just... Okay, so the product that we designed is called a shoe care atomizer. So a lot of times when people get new shoes, they're scared to wear them out because they don't want to ruin them or have any spills on them. So Ash Industries wanted to produce a consumer-friendly product that will allow people to wear any kind of shoe they want in any kind of weather condition. So our solution utilizes flat tip nozzles, a shoe protection spray, PVC pipes, and a water pump. And basically you could put any liquid you want into the box next to our product. And the water pump will allow for the liquid to flow through the PVC pipes and for the nozzles to spray onto the shoe.
All right, thank you so much. We'll be moving on to our next presentation. Just give us a brief moment, sorry. Right, do we have to hold this? Yeah. Okay.
Left it or no? Okay, so okay, so for our project, we decided to make a sandwich maker. So the main issue we were trying to solve is that customers at sandwich restaurants, you expect something good from like Subway, Jersey Mike's, something like that. But it often produces health violations and long preparation times. It's simply too slow. And so we want to automate a lot of this process into a single machine.
Yep, so I don't know how well you can see it, but up here on your top left, we just have some stats to corroborate those statements. For example, according to NBC News, Subway reports up to 60% of workers make mistakes that could be potentially hazardous to your health. And there are a lot of other things like that, making for a triple negative where customers aren't getting their food on time. And even though it's late, it's not as good as they want. And because of this, the companies are paying for it. Again, I don't know how well you'll see it, but on the bottom left, we have our past solutions. So up here is called the Hamilton Breakfast Sandwich Maker. That one is circular and small, which is a positive and also a negative. It's small, so it can be moved around very easily, but it's small, so it can only handle specific types of bread. This one, because it's for breakfast, it's really only going to handle English muffins and bagels. And that's obviously not the only type of sandwiches people make. Right below that, right here, is an electrical sandwich maker. All that's really automating is the heating process. So you're still putting together the sandwich yourself, and then you're just putting it in there to heat it up in the end. So our goal with these 10 solutions was to put together all of the best advantages and functionalities and eliminate as many as we could of the disadvantages.
So working with the advantages of these similar solutions, we came up with the design specifications and constraints for our design. Our design actually met most of these, it only didn't meet two. It is heavier than 17 pounds and it cannot dispense toppings and or spreads, but it passed all of our tests, so it can make your sandwich, which Sean will explain the process.
Yes. So if you want to move the camera over here, this is our build. So we're taking one of the walls off so you guys can see the internals. So there are 6 slots right here. Can they see the 6 slots? Okay, so there's 6 slots up here. The first one is for bread and the last one's for bread. And then the other 4 in the middle you can use for meat, vegetables, whatever you want. And there's a door right here. So as you drop the ingredients get suspended on these doors. You have to make sure that it doesn't fall down. Now, you pull this door manually and the ingredients fall down. And at that same time, this L-shaped piece, which is wired to an Arduino over here, if you want to turn this around, it's an Arduino and a motor setup. It's a very linear code, but it's wired here. And as the ingredients fall down, this hot plate over here starts moving towards this hot plate, and it compresses the sandwich here. And then the hot plate is turned on, heating both sides for a variable amount of time that you can change. And then the sandwich falls down, and you have your sandwich.
All right, thank you guys so much. We're moving on to our next presentation.
All right, hi everyone. Our project was to create an interactive tennis net frame. Yeah. So we're all tennis players and we wanted to create some sort of tennis training equipment because when we were researching online, similar products cost over $300. And according to our market research, not many people were willing to buy such an expensive product. We try to find some similar solutions online, but they cost like $300 to $400, and they weren't as complex and usable for tennis players. So we designed our model on Autodesk Inventor on a computer and then constructed it in real life. And I'll let Marcos talk about the features of our product.
All right. So one big part of our design was to introduce technology into it. So what we decided to do was have randomized LED targeting systems. And you can see right here and into the actual net, you can see the randomized LEDs. And what those do is they represent different quadrants of the tennis net. So basically you would target that specific area as the LED lights up. And then as you hit it, it would randomly change to a different area. And then you would have to hit that area as well.
We also wanted to make our net very adjustable, and we accomplished this by adding some screws here. You can adjust the tension of the net by moving it onto different squares like so. So you can control the type of bounce that you get. Also, it's a little difficult to see here, but we have placed many different holes along this PVC pipe, and you can adjust where the pin goes to adjust the angle at which you can hit this net frame at.
In addition to that, we also figured that portability would be a pretty useful feature for us to have. So as you can see, we have these connectors right here, which allow you to disassemble the PVC. And then you can also take the net off of the screws. And as you can see in our poster board, you can fit it into a small car like a Prius, and it fits nice and easily. As well as that, is also very lightweight. As you can see here, Rona is measuring it on a scale, and it only weighs about 20 pounds. So with all this combined, it makes it very easy to travel with.
A big focus of our project was trying to make this as cheap as possible to make it more accessible. And our market survey showed that like people would be willing to buy a product under $100, and our final product cost was $85.85.
All right, we're gonna do a demonstration now. Thank you so much.
Who's doing problem statement? Rahul. All right, Rahul, you do the problem statement.
Our problem statement was, so because of the onset of COVID-19, we saw a huge number of our population become depressed and suffer a lot of mental health issues. So my group and I decided to find a way to try to combat this. So the way we tried to combat this was by trying to make a strength training machine, which you would be able to work out all your body parts, so your arms, legs, everything, and this would make you feel better and happier.
Huh? All right, so
All right, so our justification for this is we sent out surveys to a couple of professionals, and we sent out to our classmates as well. We also did a lot of research on some studies, and we found out that the majority of people do have this problem, and they do feel like depressed. So we looked up a few similar solutions like the Bowflex and a couple of others, and most of them had the same problem. They were either way too expensive, so 750 plus upwards of 1,000. They were too complicated to set up and use, and well, yeah, they're too complicated to use, and that leads us on to that Paul. There you go.
all right, so the solution we came up with was a combination of a lot of different ideas. We sort of chose a really versatile idea. Basically, the idea is that instead of changing the weight, like I don't know if you've ever been to a gym and you like put the pin in different weights, we have one weight, but we change the mechanical advantage. So it's easier to build, it's simpler, there's less moving parts. And I don't know if you can see here, but our CAD design sort of shows like exactly the scale of the machine and how it would work, which helped the build go really well. But yeah, we wanted something very versatile that would fit in someone's house and met all our criteria. So.
All right, so for the building process, we basically had used a lot of 2x4s, 4x4s, metal fasteners, and occasionally we used a metal pull, like these plastic pulleys. So one issue we had with the wood was that, if you want to point it towards the machine. So one issue we had with the wood was that in certain parts, it actually started cracking due to when it dried, it started to crack. And then we also had an issue with warping. So we had to replace where we were going to place our supports, which would allow it to basically unwarp the wood and kind of bend it back into shape. So that basically was how we built the main structure. Now for the concrete, it basically went as smooth as mixing concrete can actually go. But then we reached the hardest part, which is the pulleys. Now the pulleys initially were going to be used with 550 paracord. An issue with that was that we had to like quadruple band the rope to be able to lift it up. And then the initial pulley design also had the issue where it's like, it kind of stressed one side of the pulley way too much, which ended up actually breaking the pulley by ripping off one of the sides. So we ended up putting a 2x4 on the top to sort of support it a bit more, so it wouldn't like the rope wouldn't favor one side and it would keep it in the middle of the pulley. And then due to the stretchiness of the paracord, we ended up switching to a less stretchy rope, which is the red rope as you see there, which allowed it to function as intended. And as you see, we have Paul doing a demonstration right now. All right.
Thank you guys so much.
Oh, tell me when it starts. Oh, yeah. Move closer. Okay. All right. My name is Adrian. We're group A2I2. This is Belle, Isaiah, and Aditi. We made a portable cup holder.
So our justification for making this project is that nearly half of all Scout injuries are caused by hot food and beverages. And also while doing our research, we found that in a survey, nearly a tenth of all people spill their coffee occasionally while they're drinking it. So we decided that this was a big enough problem for a solution.
And as you see here with our product, it's mostly made out of 3D plastic from like 3D printed parts, right? And if you see right here, you can't really see it good, but it used to be two pieces. Right now, it's one. It looks one big piece. If you try pulling apart, can you demonstrate that, Bill? Just you see, it stays are really good because of the way I tighten it together. And it also has a clip here that is more or less used for when you're sitting down. So when you sit down, the drink does not spill out at all.
This is our final design. However, you can see that we had many hurdles along the way. This was our first design. As you can see, it's pretty small and it could only fit a Dixie cup at the time. So we had to work around that a lot. As Isaiah said earlier, we also ended up adding these two little axles inside of it. It might be a bit hard to see, but there are two axles that keep this spinning like that. So when it does, no matter how your position changes, it'll always stay upright.
All right, thank you guys so much. We'll be moving on to our next presentation.
Oh, sorry.
Yeah. All right. So here at Athletics, we've noticed two problems. In the 2013 and 2016 NBA season, there were 769 ankle injuries in the NBA, making up 25% of the players. We've also realized that there's something wrong with the shoes. They're flimsy, unresponsive, and restrict movement of the players. Some solutions we've looked at are Nike Air, Nike Zoom Air, Reebok Pump, and Adidas Boost. After going over our solutions and modeling them, also coming up with our own solutions, we've come up with our prototype.
Just hold it. So, so for this prototype, the main thing we tried to address is the ankle injuries, obviously. So what we did is we had this thing called a drop-in midsole, which is where you can take the foam out of the shoe and put it back in. And the main way this addresses ankle injuries is that the sides of the shoe don't compress, which means that when the sides of the shoes compress, that's when your ankle rolls. So that's the main way we addressed it. And obviously, if we had more time, we'd redo the upper because we weren't really focused on the upper. We were more focused on the midsole. So we'd focus on the upper to add more material on the sides, and we'd make the midsole less boxy, basically, if we had more time.
Thank you for listening.
All right, thank you guys so much. We'll be moving on to our next presentation.
All right. Hi, we're Caps, and this is our supremely silent shower curtain. So basically, our idea was to create a shower curtain that reduced sound overall, and house value severely decreases when our shower curtain when showers are very loud and noise pollution is in the area. House value severely decreases. So we ran a survey of some students, and about 70% of them wanted to have quieter showers. So we decided that, building a soundproof shower curtain seems like a good idea. So for our original idea, what we had was a clear shower curtain that has melamine foam in it, which is a special type of foam that is used mainly for insulation and is pretty good at blocking out all sound. Another idea we had to incorporate with the melamine foam is to have a speaker that, if you guys know how noise canceling headphones work, they invert the sound that is brought into your headphones. And our idea was to invert the sound that came from the shower curtain, and that would basically reduce the overall sound that our shower curtain makes.
So our final design had smaller pieces of foam in it so that we could fold the shower curtain so that it would be more portable. And then it also had the speaker that was gonna produce the sound, the inverted sound. And so when we tested it against a regular shower curtain, and that was a little bit interesting because of external noises made it so that the results weren't accurate. But then when we tested it to see if it was waterproof, because that's also a very important part of it, it was waterproof because we completely dunked it in water and nothing got in. So overall, our project didn't work as well as we maybe wanted it to, but it was still very interesting.
Thank you so much. We'll be moving on to our next presentation.
All right, hello everyone. All right, so hello everyone. My name is Isaiah. This is Bryce. That's Tommy and Adriana. So you can start off with our problems.
All right. So every year, a big problem with what's up? All right. A big problem with planting is that about 50% of plants die due to over or underwatering, which is a big issue.
All right, so we polled nearly 200 people and found out that their biggest issue was with underwatering and also overwatering. So we found some similar solutions to that problem, and here are some of them right here. But then we decided to come up with our own.
So some of the criteria that our box had to go through is that it needed to be self-sustainable with monthly checkups. So, and also that our box had to look visually pleasing and it should prevent mold. Our box, yeah, it passed all those criteria. We made sure that it had no mold and it looks pretty nice too.
All right, so for our original design, what we originally wanted to do is use a large plastic pot and cut it in half to have the two sections like we do in this one. But we quickly found out that would be near impossible to cut that plastic pot in half with the resources that we have. And the structural integrity of it would be very poor. Also, our original idea for the airflow, we would have slits. And in the redesign, we decided to make the entire thing out of wood, and it's flex sealed in silicone, so it's able to hold water. We did a rectangular shape so that it would fit all of our internal components properly, and they wouldn't be flying around like they would be in the circular plastic pot. And instead of those slits, we used holes because they would be easier to implement onto our prototype.
All right. So on the bottom here, we have a water reservoir, and in the water reservoir, we have a dehumidifier that collects the water from the air and puts it into the water reservoir, which the pump takes up from the bottom to the top of the plant, where there's a tube that circles the plant and releases the water into the plant when necessary. It's it's connected to your phone, so you can turn it on and off based dependent if the plant is dry, or dependent on the plant's needs. Some plants need to be watered every week, or some every 2 to 3 weeks, and you could put it on a schedule. And so basically, the water reservoir is just replenished by itself by the dehumidifier, and it's self-sustainable.
All right, so in the end, we tested every part of our plot and everything worked except for the dehumidifier. The first dehumidifier, it did break, and we believe that's because of the water that got into it and it fried it. But in the end, our second dehumidifier did work and our entire project was successful. Thank you.
Thank you so much. We're moving on to our next presentation.
That's very cool. Okay, that's very cool.
Hello, everyone. This is our ShareMu chair. It is a product designed to help support the posture and comfort of musicians. It has, if you want to like pan down, Ronan, it has a telescoping leg down here so we can adjust the height as needed. And it also can slide back and forth depending on how much chair space that the chair musician needs. It can also fold down with handles for easy comfort. And it is built with 2-inch memory foam fabric and a vinyl fabric so that it's very waterproof and also very durable. So you don't need to worry about getting it dirty, which often happens in music classes.
So after testing the chair, we found that most of our criteria were met. So we had 6 criteria, which were adaptability, comfort, durability, ease of use, stability, and transportability. Under our comfort criteria, we had a sub-criteria of stability, and that's the criteria that we came across the problem during testing. So in order to solve that in the future, what we would do is instead of using mostly wooden and PVC components,
we would replace those with metal components. So for example, instead of using the wooden base, we would use a metal base that you can typically find in kitchen chairs. And then instead of using a PVC telescoping leg, we would use a hydraulic lift pump that you can find in office chairs. And the base of our seat in our back of the chair is made out of wood currently, but instead we would use a 3D printed plastic component that would provide a lot more stability and durability. And lastly, we have lumbar support right here to help support musicians' posture and back. And so currently you can see that it doesn't stick out very much. Therefore, it does not provide as much support as we would have liked. That's something we would definitely add in the future to make sure the chair is in full effect. Thank you.
Thank you guys so much. We'll be moving on to our next presentation. Sorry, just give us a few moments. We just have to wait up for this presentation to be done.
Here, all right. Hi, so my name is Agil Ganashankar. This is Matt Zupan, and these are our teammates, Alwyn Jacob, Brian Corsiga, and Adarsh Patel. Our product is based off the problem of the lack of prevalence of recycling in the home environment. In general, although a lot of people, according to our market research, believe that recycling is very important and very integral to society as a whole, they don't know how, when, or what to recycle perfectly. So the idea is that even though a lot of people really want to recycle, all they know about recycling is that you take plastic and ship it off to a faraway facility. They don't really know a lot about it, and because of that, it's not very prevalent in their lives. In order to fix that, we decided to create a product that allows people to recycle within their homes themselves, and hence it becomes more prevalent in their lives.
So the product that we created consists of 3 separate sections. We have the first section, which is our molding section, a second section, which is our hydraulic section, and the third being our safety features. So the first section being our molding system, basically how it works is we have 2 large boxes stacked on top of each other, which have 2 smaller boxes, almost tube-like, which you would put your plastic in, like jugs, plastic water bottles, basically anything else that you want as well. And then those 2 boxes, 2 large boxes, move up and down on 4 steel rods that act as rails. So then for our safety features, what we have is a long sheet of wood with a hole in the center of it, which allows for our hydraulic system to move safely up and down without ever falling over.
As Matt mentioned, our product is basically a hydraulic stamp to crush and mold plastic in any desirable way that you would like. So the only phase that Matt did not mention was the hydraulic system. And the hydraulic system is basically an acrylic tube located here that is housed inside of wood. At one end of the acrylic tube is an input piston, and at the other end is an output piston. When the input piston is screwed in, the water pressure inside the acrylic tube increases. The acrylic tube is filled with water, and that water pressure in turn pushes out an output piston on the other side. That output piston pushes down directly into the mold boxes that Matt mentioned earlier. Within the mold boxes would be plastic that you would mold, and when the output piston pushes out into the plastic, it crushes it and molds it into any desirable shape as you choose.
So our last thing that we had to go through was our testing phase. So to test our thing, what we did is we used a plastic water bottle, just a standard one, and what we tried to do was crush it.
So in our testing phase, we had criteria that we needed the build to be durable so that it would actually last, that it would be waterproof, and that it would actually be able to crush the water bottle itself. So we were able to crush the water bottle, and it was also durable as it did not break. However, the only problem that we faced was that our build was not able to actually be fully waterproof, and it had quite a few leaks in it.
Thank you so much. We'll be moving on to our next presentation. Yeah.
All right. So with bread being one of the most conventional foods on the planet, we wanted to solve an issue that many people face every day when it comes to bread. Twist ties take much too long to use, and there's a higher chance for the growth of mold and fungi if not closed properly. That is a major inconvenience, and because of that, we decided to create the Mac bread bag. Moving on to our business statement, we revealed that if 32% of bread was wasted in US markets in 2016, some of that bread must have been due to the growth of fungi. The existing bread bag clips and twist ties don't fully accomplish the goal of tightly resealing the loaf. Resealable bread bags would properly lock the bread in and not allow for air and moisture to get through. Down below in the middle of the trifold board, we have some images and screenshots of our completed product, as well as some CAD drawings to follow on the left.
Before we got started, we wanted to get some information about consumers and their bread. So we released a survey that tallied close to 150 responses. We asked consumers how often they buy bread and how often the bread airs out, in which an overwhelming amount of people had answered weekly and occasionally respectively. We also asked how inconvenient bread bags were to operate, and the majority of 65% chose the level of inconvenience at or above a 3 out of 5. Additionally, 63% said yes to our final question, which was, would you prefer to purchase a bread bag? Get much more timely.
So for our similar solutions or solutions, that have previously existed, we actually had 7 of them. And all of those products, they actually specialized in storing bread. Well, compared to our product does a lot better job at storing bread because of its material, its design, and other unique products. So as you can see, inside the bread bag, it's actually made out of linen, and it's actually surrounded with beeswax paper. And so this beeswax paper is actually really good at trapping moisture, this is why we chose it in the first place. And we also used a mold inhibitor, which actually stops the growth of mold, and that's because it's a preservative.
All of our walls, bases, and top pieces onto our main material, which was the linen. We then cut out all of the pieces and attached them to the base with the fabric glue. We continued gluing the sides to the base as well as to each other, and we used binder clips to hold up the assembly while we put together the top. We applied the mold inhibitor preservative onto our linen as well, and we finally added our beeswax paper to the outside. You can see the process we went through with the pictures on the top right side panel.
For moving on to our testing and results, we used the same bread from the same company with the same expiration date in order to keep those variables from affecting the result. We put one Mac bag in the fridge with a regular bread bag and one in the pantry as well as a regular bread bag, as people store their bread in those two primarily different ways. Over the 14-day period, we opened up the bags twice to weigh them to see if they lost moisture, and we did this on days 7 and 14.
We found out that there was a rapid decrease in mass on the half loaf immediately after we opened the bag on day 7. We found out that the Mac bag did slightly worse in keeping the bread fresh, as there was a 200% higher loss of moisture in the Mac bag than the store-bought bag, which means that the Mac bag did not accomplish its freshness goal. The Mac bag did although excel in the time test as well as the cleanliness test, as it took far less time to open and was much more effective sanitation our zipper to empty cups. Not, however, passing the materials test as it was not a clear material like we originally wanted.
Okay, so overall, um, our product had 5 constraints in total, and our product actually met 3 of them, making it a really successful product. So in the future, what we want to do is that we actually want to fix the material up a little bit, and so that will make the results a lot better. And so in the future, what we want to do is that we want to put these in a store, make it a one-time purchase, so that when you buy bread and the plastic bags you can throw away, take out the bread, and then you put it into this bag that we have as our product. And so that'll preserve it for a long time. You can take it out whenever you want. So yeah, that's the end of my presentation.
All right, thank you so much. We'll be moving on to the very next presentation.
That's too much work. Thanks, guys. All right.
Okay. I'm Jillian. This is Arushi and Alexa, and our product was a modified crutch. So a study from the CDC found that 13.7% of people with mobility issues had trouble going up and down stairs. We also did our own research, and of the 40 people who responded that they had used a mobility aid before, 94% said that they still had trouble going up and down stairs. Regular crutches try to help with this problem, but they can be uncomfortable and they can be dangerous if a person falls, and they could injure themselves further. So we decided to make our own crutch to try to help with these problems.
Yeah, so first we decided to look at some solutions that already exist to help us get some ideas for our own project, and we brainstormed our own ideas as well. We used a decision matrix to help choose our final design, and we ended up making a lot of modifications. For example, as you can see here, we added a stair rest right here. So how the stair rest helps is that you can put it on the following step while you're climbing up the stairs to help you stay balanced while you're using the crutch. We also added a pouch where you can see the highlighters are inside in the net pouch. And that's so people can carry personal belongings while they're using our crutch as well. And finally, we added foam padding to our crutch to make it a lot more comfortable to use, because we noticed that with traditional crutches like this arm part creates a lot of armpit bruising because it's so hard on the skin. And so we thought the foam would be a good idea to help combat that problem.
Yeah, we also wanted to make it more versatile. So there's many ways to hold it. You can hold it down like this and it hits your hip so that it's not going to bruise your armpits, and your hip is already made for carrying things. You can use it as an elbow rest, or you can hold it all the way up here. And it's also adjustable depending on how long your arm is. You can move it up and down. And also at the bottom, we have a block that's way bigger than a traditional crutch, so it's way more stable. And so to test it out, we had people who have already used crutches, and we had them use ours on a staircase. And as you can see with our test results, most people found it more convenient to use our crutch. Most people were able to use the pocket. Most people found it very comfortable because we did it on a scale of 1 to 5, and most people were 4s and 5s. And we also had people determine if it added more time or stayed the same. And most people put that it was faster or stayed the same. So because of this, our crutch is safer, more convenient, more easy to use, and safer. Oh, and more comfortable. Thank you. Yeah.
Thank you for that presentation. Moving on.
Just speak. All right, so for our product, we wanted to address the issue of right-handed products dominating the market. So we wanted right-handed products dominating the market. So we wanted to create a product that would be usable by left-handed people that are underrepresented. Sorry, I can't talk. And also make it convenient for. and also to make it convenient for right-handed people to use. So we created a desk that it has both a right armrest and a left armrest. And some of patents for the for solutions that we were going to look into were a circular saw that would be like portable and usable by both like left-handed and right-handed. And then also a desk that was similar to ours, but instead of there being two armrests, it was a reversible armrest where it could be changed either a left-handed or right-handed.
So now we're gonna show you how it works. Now we're gonna show you how it works. You want to bring the camera closer? So right here we have hinges so that the actual like desk part can flip, and it's connected to a piece of wood connected to an arm right here that comes down to the chair. So how it works is we'd open it up. We'd open up the desk, come and sit down, and then now it's easier for both right-handed and left-handed users to use because there's both a left-handed side and a right-handed side.
So trying to make sure to see if our product was actually functioning, we took a survey for testing to see how people felt towards the ease of use of our product. So we had a group of righties and a group of lefties come and test it. So a majority of right-handed people said it was like a 6 and a 9, and the majority of them said it was a 7. Meanwhile, we asked left-handed people, and they said that it was an 8 out of 10 for ease of use. So overall, left-handed people seem to have a generally more positive response towards this desk than right-handed people. So our ultimate goal was to make sure that left-handed people do feel comfortable, but also not deny righties the privilege of using this desk. Thank you.
Okay, thank you for that. We'll be moving on to our next presentation. Just give us a few moments, sorry.
Hello. I'm Cameron. I'm Andrew. I'm Brandon. That's Alan. All right. So, yeah. So soldering irons. Is it? Wait, which class is this? Is it like this is like an older class? Older class, right? They're not freshmen. Parents? Okay. So so soldering irons, you know, they get okay. Soldering irons get pretty hot, and they'll get up to 350, 360 degrees on average, which is enough to cause serious burns. So they're dangerous if not used correctly. So we have some incident reports here of soldering irons causing injuries, and those are only hospitalizations, which would be on the severe end of cases. So there are a lot more minor injuries that can happen at homes. You can just wash it off, get some medicine on there, it'll be fine. So we've got some past patents there, and Andrew here, we actually have a firsthand experience of an injury.
Yeah, so while building this project, using the unmodified soldering iron, because we took an existing one and then kind of modified it with our own circuits and stuff. So while using the unmodified one, I actually got a burn here, as shown like on the board here. I actually did get a burn from doing this. So we have firsthand experience now of like getting a burn from using a soldering iron. So the hope is we've made several modifications to it to help improve the safety of this soldering iron. One example, we added what's essentially a heat sink here. It contains some metal. And the idea is when you're done soldering, you can stick it in there and it'll help to draw away the heat more quickly. Another thing we did, there is there's a foot pedal here. The idea is you have to always be here for the soldering iron to run. If you were to walk away, forget to unplug it, it'll just stop heating up and it'll gradually cool down on its own. So that way you won't have any issues with unattended soldering irons that are super hot. Another thing we did, we added a temperature control. So this is essentially a power knob. And yeah, so here we can kind of demonstrate how it works. So we're standing on the foot pedal here, and we can kind of control the power going through it. Those LEDs that are actually being powered by the wall outlet as we switch it with this circuit here. So you can see as I turn it down, it's only flashing a little bit, whereas as I turn it up, it's on much brighter. So yeah, so that's our overall circuit. We went through a lot of iterations to design this circuit because it was completely new to us, working with wall outlet AC and controlling it and being able to turn it on and off. Oh, Brandon.
So this is our first build of the stand. Due to a printing error with a 3D printer, there's some building materials still on it. This was overly large. It shouldn't be this big, so we redesigned it for this smaller one. Between the time of printing the first one and printing the second one, we acquired this piece where you would put the soldering iron for it to hold. This is where you put the sponge, which essentially is just to help clean the soldering iron between uses. So if we manage to put the circuit inside, the knob would go here, and then the LEDs would go here to show it blinking.
All right, thank you guys so much. So that basically concludes all of our EDD Showcase presentations on Zoom. We did record this session onto the computer. So if you guys did miss any ones, or if you want to see all the other ones, we will find a way to send that out to you guys. So yep, thank you guys so much for joining us, and have a nice rest of your day.
Thank you.